This time, we will present the aluminum panel used for the construction of DDP. Let's learn about the benefits of using aluminum in exterior materials. An aluminum panel is a sandwich structured panel with a low-density polyethylene materials between two aluminum coils. It is cheap and has various functions. The aluminum features smoothness and corrosion resistance. Aluminum itself has a high corrosion resistance, so it prevents corrosion from sinking and can withstand heavy rain. Also, the sandwich structure of aluminum has excellent insulation, which enhances blemish and sound insulation. Compared to the metal plate of the same thickness, the aluminum weight is light from half to one-third, and this makes it easy to transport or install, making it highly constructive. It is DDP that 45133 aluminum panels are used. At that time, Samsung C&T was the first in the world to manufacture and make secondary curved molding and cutting equipment. As I explained earlier, the optimal number and size of panels are calculated through computer simulation tasks. As a result, the appropriate number of panels covering DDP was calculated to be 45133. This picture shows the simulation results of panels. The red is secondary curved surface account for 49%. Orange is the primary curved surface account for 22.4%. And light green is the flat surface account for 28.6%. The 3D modeling of aluminum panels achieved by BIM. What is different from simple 3D modeling is that all computer-worked components contain building information. In other words, aluminum panels surrounding the outside have architectural information about their own size and curvature, and are built and constructed based on these factors. A space frame consisting of a double space frame, a single space frame, and a powering system was used for structural review, after generating wireframes, first through automation capabilities. Thanks to architectural information that each panel has, it has been a great help in the process of producing panels that will be explained later. The stability of thin and wide panels has been enhanced through the stiffener. The installation process of the panel structure is to install the space frame first and then install a 2 mm high-strength zinc plate. After that, install insulation, plywood, and water repellent, and finish by covering aluminum panels. DDP had to use special external panels to implement unstructured facade. How did it make these panels? Before know that, we need to first look at the types of external panels. First, it is the most common flat panel. The panel itself it is not subject to curvature. But these flat panels can be also connected to achieve curvature. However, these flat panels cannot implement the amorphous nature of DDP. Next is the primary curved panel. Only one direction of the axis has curvature. In this case, the curved part can be unfolded to create a flat panel again. On the contrary, this means that even a flat two-dimensional mode can be used to create a primary curved panel. Although complex curvature can be implemented compared to flat panels, there is still a limit to implementing DDP amorphousness. Next, it is a secondary curved panel applied to DDP. Unlike primary curved panels, both axes has curvature. Therefore, panels cannot be unfolded in a two-dimensional plane. Therefore, it can be produced unconditionally in three dimensions only. For the 45133 panels, DDP has 45.2% of secondary curved panels, totaling 21,735 panels. Although secondary curved panels have the advantage of being able to have a solid exterior and finish because there is no gap between panels if they are properly constructed. There is a problem with production and cost. How did DDP address this issue of production and cost? It is necessary to first look at how panels are produced, then how to make panels. The first method is stretchy forming. First, on a bent die with curved surface, the panel is stretched to form a primary curved surface. First, mark it with a pen. Then pull the metal to the marked point. The second is die forming. Create a curved surface by press the panel on top of a curved mold.
So the idea of
In both of these ways, in order to create a secondary curved surface, one must produce the corresponding mold, and DDP has a different shape of each curved surface, making it impossible to produce each of these molds.
behind it is to form sheet
Next is single-point incremental forming.
metal using a tool such as this without cutting flutes. This one happens to be carbide. It's probably a more scientific way to apply it. To go above. So now I can double check and make sure that my shot looks like what I thought it was going to look like. So we can approximate the thickness of our formed part with the sine law of sines. So we know the...
Unlike the former method, without molds, the point presses the plate to create curvature.
thickness of the material we start with, and we know the angle that we're trying to form at. So if we're noting this, you want to know we're spinning at 600 RPM. That's our spindle speed.
However, it takes a lot of time to mass produce, which is not suitable for DDP.
Feed rate is moving at 350 inches a minute.
So yeah, you can see the little ridges.
So the method chosen during DDP construction is multi-point stretch forming. There was an existing multi-point forming method. This method was to make several posts into desired molds and then press metal plates on them. However, this method left round post marks on the panel itself and did not produce a clean finish surface. Therefore, DDP used stretch instead of press by placing rubber plates on top of conventional multi-point forming. However, at this time, there was a problem that the panel was partially twisted. To prevent this, multi-point forming was installed at the top as shown in the picture. After that, the construction work was completed by cutting the necessary parts of the finished secondary curved panel. Each multi-point forming model takes information from BIM and builds it panel by panel. Through this work, the cost of producing each panel was reduced from $7,000 to $260, and the construction period was shortened. This is because production time for each panel has decreased to 15 minutes. These are reference lists of today's presentation. And next time, we will present internal finishing construction. Thank you.